Hi everyone, I'm Professor Martin, and I'll be the instructor for this online introductory astronomy course about stars, galaxies, and the universe. It's a great course and we have lots of exciting material to explore this semester, and I'd like to begin by giving you an overview of some of the topics that we'll talk about in this course.
We'll begin the course by talking about the scales of things and where we are in the cosmic perspective. How big are galaxies? How big are stars? How large are we compared to atoms? And where do we fit into the nature of things? We'll also discuss the dynamics and laws that govern the cosmos. Laws such as gravity, electromagnetism, Kepler's laws, and the laws that govern the dynamics of orbits of bodies, including the sun, stars, and planets. We'll then move on to talking about light. Light is very important in astronomy since it's the main messenger that objects provide for us about what they're made out of, how fast they're moving, and their nature. Along the way, we also talked about spectra and spectral analysis, how we understand the nature of things. Even across the universe, we can tell what they're made out of and many of their properties. We'll then go on to discuss telescopes, which are the main instruments for astronomy, how these can gather information about the cosmos, and what are observatories and why do we place them where we do. We'll then move on to talk about the nature of stars, how we know what we know about the stars, their properties, how big they are, how small they are, their distances, their temperatures, their compositions, and much more. And we'll also focus on one particular star, which is our sun, its nature. Why does the sun shine? How big is the sun? How old is the sun? How long do stars like the sun live? We'll cover all aspects of the sun's nature, as well as its life cycle and its future. We'll also talk about nebulae, tremendous clouds of gas and dust from which stars form. What's their nature? How are stars born? What makes a star a star? We'll also talk about the life cycles of stars, where they come from, how they live their lives, and where they eventually end up. Some stars end their life spectacularly as supernovae. This is the Crab Nebula, a supernova remnant of a star that exploded over 1,000 years ago. We'll study it and other examples of its kind. We'll also study some of the most mysterious objects in the universe, neutron stars and black holes, places where space, time, and light have been so distorted by gravity as to be completely unrecognizable. As it turns out, most massive galaxies have black holes at their centers, so far from being an isolated phenomenon, black holes seem to be very common in our universe. We'll also study our own galaxy, the Milky Way. How large is it? Where are we? What's its nature? How old is it? And how are other galaxies similar or different to our own galaxy? We live in a universe that's filled with galaxies of many different types. We'll study these different types of galaxies, how are they different from one another, and how do they compare to our own home galaxy, the Milky Way. We also find that many galaxies are clumped together into large clusters of galaxies. Here's an example of a massive galaxy cluster, where there's so much mass in this one area of the universe that even light, space, and time are being distorted by this massive gravitational influence. On larger scales, we find that galaxies are clumped together in long strands or filaments that stretch across the universe. In this image, every single dot represents a single galaxy, forming long threads or webs across the universe in 3 dimensions. We'll also discuss the Big Bang Theory, a theory about the origin of the universe that says that the universe began in a single energetic event some 13.8 billion years ago. We'll discuss how we know this, what happened in the early universe, and where we think the universe might be going. We'll also discuss our place not only in cosmic space, but also in cosmic time. So it's not only a question of where are we, but also when are we? What's the sequence of cosmic events that have led up to this conversation about the universe today? So just to keep things interesting, here's a slide that shows the modern composition of the universe as it's currently known. As you can see, 73% of the universe is something known as dark energy, some mysterious force which seems to be accelerating the universe faster and faster over time. We have no idea what it is. Second most common is something called dark matter, which makes up 23%. It's something which has gravity but doesn't emit light. And once again, we have no idea what it is. Which leaves the 4%, which makes up the galaxies, the computer, the room that you're in, the earth, people around you, and everything that we see with our eyes and touch with our hands. This makes up what we call normal matter. We know a lot about that, but the rest of it, this 96%, we have absolutely no idea what it is. So the mysteries in astronomy continue, and this course is an introduction to them and hopefully an appreciation of the magnitude of the universe that we're in. So see you in the course space. and thanks for taking this course.